Good afternoon, children. Today we are going to continue with chapter 1, chemical reactions and equations. Today we are going to study the third type of chemical reaction, that is displacement reaction. Displacement reactions, the reaction in which a more reactive element displaces a less reactive element from its salt solution, is known as a displacement reaction. They are redox in nature. That is, in these reactions, reduction and oxidation takes place simultaneously. For example, we take a general reaction, taking a compound which is AB and add C to it. Here, since C is more reactive than A, it will displace A from AB and hence A plus BC will be formed. We take example over here, next example, that is of displacement reactions, that is we will be taking 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B, and in each test tube we will take about 10 ml of copper sulfate solution. The color of copper sulfate solution is blue. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 10 to 15 minutes. Keep 1 iron nail aside for comparison. After say about 15 to 20 minutes, take out the iron nails from copper sulfate solution. The color of the solution in test tube B changes from blue to light green. The difference in color of the solution in the test tube A and B indicates that a chemical reaction has taken place in test tube B between iron and copper sulfate. Also, we observe change in the color of iron nails immersed in test tube B. They get coated with a brown covering. Since iron is more reactive than copper, hence displaces it from its salt solution, forming ferrous sulfate and copper. Here, students, you can see the test tubes in which iron nail. In the first case, the color of the solution is blue, and in the second case, the color of the solution changes to pale green. In the first case, the color of iron nail is black, whereas in test tube B, brown color coating of copper takes place on the iron nail. The chemical equation which has taken place can be represented as Fe plus CuSO4 will give FeSO4 plus copper. Color of ferrous sulfate solution is light green and copper is red-brown in color. If we touch the test tube containing the reaction mixture, we feel that the contents are hot. This shows that this reaction is exothermic as well. There are more reactions of displacement reactions. For example, take a zinc granule, place it into copper sulfate solution. After some time, we will see that the blue color of the solution changes to colorless solution and red-brown copper is precipitated out. In this reaction, Zn plus CuSO4 will give ZnSO4 plus copper. If we take lead rod and place it into copper chloride solution, which is greenish blue in color, after some time, PbCl2 and copper are formed. So in these reactions, zinc and lead are more reactive than copper. They displace copper from its compounds. Metals differ from each other in their reactivity. Some metals are highly reactive, some metals are moderately reactive, and there are very few metals which are least reactive or do not react at all. The series series in which metals are arranged in the order of their decreasing reactivity is known as reactivity series or activity series. The metals towards the top of the reactivity series can displace metals below them in the reactivity series. Next type of reactions, that is the fourth type of reactions, called double displacement reactions. The reaction in which there is an exchange of ions between the reactants are called double displacement reactions. The general equation is given as AB is one compound combines with CD, which is another compound. Here A will combine with D and C will combine with B, and the new products AD plus CB are formed. So two times the displacement takes place. Hence it is called double displacement reactions. We take an activity in NCERT book 1.10. Takes about 3 ml of sodium sulfate solution. It is colorless. In another test tube, take about 3 ml of barium chloride solution. This is also colorless solution. Mix the two solutions. We will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is called as a precipitate. Any reaction that produces a precipitate is also called as precipitation reaction. The white precipitate in this case which is formed is barium sulfate, and the other product formed is sodium chloride solution, which remains suspended in the solution. So students, the chemical equation for this reaction is represented as Na2SO4, AQ represents aqueous solution, plus BaCl2 aqueous will give BaSO4, a white precipitate of barium sulfate, plus 2 NaCl. That means sodium chloride is formed in the solution, or it remains in the solution. Now students, you can see the three test tubes. Sodium sulfate solution taken in one test tube, colorless solution. Barium chloride is also a colorless solution. When we mix them, we can see in the third case a white color precipitate and a solution is formed. That means two new products, barium sulfate and sodium chloride, are formed. If we keep the test tube undisturbed for some time, we will find that sodium chloride solution, which is colorless, will form the top layer, and barium sulfate will form the lower layer. Now when we touch the test tube containing the reaction mixture, the test tube feels cold, indicating that the reaction is endothermic in nature. There's another reaction of a double displacement reaction, example which we can give, reaction between lead nitrate and potassium iodide. For example, when we take lead nitrate solution and potassium iodide solutions, both are colorless solution. When we mix lead nitrate solution with potassium iodide solution, then a yellow color precipitate is formed, and the other product is potassium nitrate, which remains in the solution. So in this case, the products are potassium nitrate, which goes in the solution, and lead iodide, which is a yellow precipitate which separates out from the solution as an insoluble substance. So this again is an example of double displacement reaction. Now the next type of reactions, which are called as redox reactions. What is a redox reaction? Or we also call it as oxidation and reduction reactions. Reaction in which oxidation and reduction reaction takes place simultaneously. Such reactions are called redox reactions or oxidation and reduction reaction. Now students, what is oxidation? Oxidation means gain of oxygen by a substance or loss of hydrogen by a substance or loss of electrons. This process is called oxidation. If a substance loses oxygen or gains hydrogen or gains electrons, this represents a reduction process or a reduction reaction. So I repeat, when a substance gains oxygen or a substance loses hydrogen or when there is an electron, loss of electron by a substance, it shows oxidation reaction takes place. And if there is loss of oxygen or gain of hydrogen or gain of electrons, it indicates reduction process or reduction reaction. Students, this is an activity 1.11. We take a china dish, take about 1 or 2 grams of copper powder. Copper is red brown in color. Now we start heating this copper powder in the china dish and the surface of the copper powder becomes coated with black cupric oxide, CuO. In this case, oxygen is added to copper and copper oxide is formed. If hydrogen gas is passed over this heated copper oxide, the black coating on the surface turns brown again. What happens over here? The oxygen added to copper is taken away by hydrogen, giving back copper. So here oxidation and reduction reaction is taking place simultaneously. The equation is given as follows. Copper, when it is heated strongly in the presence of oxygen, it forms cupric oxide, CuO. Equation is 2Cu plus O2 on heating gives 2CuO. Now this CuO, if we take it past hydrogen gas, on heating it will again get converted back into copper and water is formed. So students, we find that in case of copper oxide, oxygen gets removed. So here reduction is taking place. This oxygen will get added to hydrogen. So hydrogen is getting oxidized. So copper oxide is getting reduced to copper. Hydrogen is getting oxidized to water. So in this case, oxidation and reduction reactions are taking place simultaneously. Hence, this is a redox reaction. Here, copper oxide is the oxidizing agent and hydrogen is the reducing agent. What is the oxidizing agent? The substance which gives oxygen or removes hydrogen is an oxidizing agent, and reducing agent is the one which removes oxygen from a substance. Such a substance is called reducing agent. So here copper oxide is the oxidizing agent and hydrogen is the reducing agent. There's another example which is given. Copper oxide, when it is heated with carbon, will give copper plus carbon dioxide. Here copper oxide loses oxygen, so we say copper oxide is reduced or reduction has taken place. And carbon gains the oxygen, so carbon is getting oxidized or oxidation has taken place. So copper oxide is the oxidizing agent. Remember, the substance which gets reduced is the oxidizing agent, and remember the substance which gets oxidized is the reducing agent. So here carbon is the reducing agent. We'll take few more examples of redox reaction. That is, take zinc oxide, heat it with carbon, we get zinc plus carbon monoxide. Here zinc oxide changes to zinc. Oxygen gets removed. So zinc oxide is reduced and this oxygen gets added to carbon. So carbon is getting oxidized and it's getting converted into carbon monoxide. So zinc oxide undergoes reduction, carbon undergoes oxidation. What is the oxidizing agent over here? Zinc oxide is the oxidizing agent and carbon is the reducing agent. Similarly, we take another example. Manganese dioxide reacts with hydrogen chloride to form manganese chloride, water and chlorine. Here manganese dioxide gets converted into MnCl2. Oxygen gets removed over here. That means manganese dioxide is getting reduced and hydrogen chloride, it gets converted into chlorine. Removal of hydrogen, that means it is getting oxidized. So MnO2 is the oxidizing agent and hydrogen chloride is the reducing agent. So students, example 1 and 2. Here we have to, you can identify the substance oxidized and reduced very easily. Okay students, next we are going to do the last topics, that is corrosion. The impact of oxidation reactions in our everyday life. One is corrosion. Iron articles get coated with a reddish brown powder when left for some time. This process is known as rusting of iron. Copper and silver also gets corroded when left for some time in the open air. When a metal is attacked by a substance around it, such as moisture, acids, oxygen, etc., it is said to corrode and the process is known as corrosion. The reddish brown powder formed on iron articles is ferric oxide, which is formed by the oxidation of iron on exposure to moisture and oxygen. Remember, rusting takes place only in the presence of water vapors and oxygen. Both are the conditions necessary for rusting to take place. The green colored coating on copper materials, copper articles, copper containers or copper vessels is due to the formation of copper carbonate formed by the reaction between copper and carbon dioxide. Silver articles become black after some time when exposed to air due to the formation of silver sulfide formed by the reaction between silver and hydrogen sulfide, which is suspended in the atmospheric air. Corrosion is a harmful process. Corrosion causes serious damage to the articles made from these metals. Corrosion is a slowly a destructive process. Corrosion can be prevented by oiling, greasing, galvanization, anodizing, alloying. So these are the different ways by which the process of corrosion can be retarded. And students, in these pictures you can see these iron pipes and all, they're getting corroded, and copper coins, you can see the green color coating on them, and iron nails and iron screws and all, they are getting corroded. So corrosion of these metals takes place. Last topic, rancidity. The process of oxidation of fats and oils is called rancidity, and we say that the food has got rancid. The smell and taste of rancid food items changes. Rancidity can be prevented by addition of antioxidants, by keeping the food items in airtight containers, by storing the food in at low temperatures. These are the few ways. Or packing the food in an inert atmosphere in the presence of nitrogen gas. Bags of potato chips are flushed with nitrogen to prevent the chips from getting oxidized, because nitrogen is a non-reactive gas under normal conditions. So we can prevent rancidity by different ways, by using antioxidants, by keeping the food in airtight containers, by keeping the food away from sunlight, also by storing the food packets in nitrogen atmosphere. These are the different ways by which rancidity can be prevented. Now students, this was the last topic we were supposed to do. Now there's a small assignment, students, for you. Do questions 1, 2, 3 from page number 13 of your NCERT book. Do questions 1, 2, 3, 13, 14, 15, 16, 17, 18, 19, 20 from page number 14, 15 and 16 of NCERT book. Students, with this I have completed the major portion of the chapter, that is different types of reactions. We have taken number of examples over here. We have finished with rancidity, corrosion, and now what we are left with is how to write down a chemical reaction in the form of chemical equation and balancing of chemical equation, which I will be taking in the next session. Thank you, students, and have a good day.